Hello, hello everyone. Good evening. Welcome to episode number 35 of the series of programming the Amiga in 68000 assembly language based on the book by Fabio Ciucci, who I thank personally for giving me this opportunity to stream his book. So let's start where we left. And last time we were doing the blitter and we did this one, lesson 9C1. I said I did not want to do the other examples because else you'll lose track. So although I did 9C1, I'm going to show you 9C1 and then we will continue with the rest. We will do also shifting. I will not finish shifting, but it will be close to finishing shifting. And then next week we'll do coloring, because so far everything that we do is 1-bit plane. So let's switch to the Amiga, which I need to get my assembler up because you're seeing the Amiga. So the lovely Asim Pro. I did just before we continue, okay? I hear a lot talking about Asim 1, okay, and Asim 1.18 mostly, okay? So I did some comparisons between Asim 1.18 and Asim Pro. There are some things that Asim Pro handles a lot better. This I didn't know when I started the series. I only selected Asim Pro because of the coloring system that it has. So, but because I was used to using Asim 1 too, not Asim Pro. However, by time I got into it more and more, and I realized that Asim Pro, I mean, of course it was released also later, so it was, but you know, I still sticked in a way with Asim 1. Asim Pro is quite a lot better. It crashes less, it has less bugs, so it's the reason why I prefer now Asim Pro to Asim 1. I mean, they're the same, it's a descendant of Asim Pro, Asim 1, in an improved version, but you know, I selected Asim 1 because of this, of the coloring, okay? Because I thought I'm going to do a stream and the coloring is visually better, you know? But by the time I'm realizing that it has other things that are a lot better, can handle things much more better, and has more commands and stuff like that. So I am happy that I have chosen this assembler over Asim 1 in terms of, you know, for us to code. So just to remind you what we did. This is what we did. We did a blit. We blitted an image, okay, to the screen in the top upper left hand corner. So sorry, I got lost for a second because I have a bit of a different setup too. Again, I'm always optimizing the setup, but sometimes when I optimize, I get lost afterwards. Anyway, So the Blit, the first example that we did is blitting an image which is more than one line. Before we were blitting only using one line. Now we have a height of six lines, I think, or 6 raster lines. So that's the first, that's where we were. I'm going to show you, okay, the next one, 9C2, and then we go to the code. So it's still a 1-bit plain image. As you can see, there are only 2 colors on the screen. We are blitting, okay, several times across the screen, X and Y, that same pattern, okay, the square box with a circle in the middle. That's what we are doing. We have that image, that pattern, and we have done it 20 times horizontally, and if I remember correctly, 16 times vertically. And this is the code that we are going to see. So let's jump to the book. And we need to go to the exercises book. Okay. So let me check that my settings are okay. That option is very important. Having a scroll. Okay, so we have a bit plane of 320 by 256, okay, and we're going to blit an image with is 16 by 15 pixels, okay, so 16 pixels width, which is one word, and 15 pixels high. Of course, the usual code when we initialize, but what we are interested is this one, fill memory. Remember, the blitter works on memory, not like when we are, it doesn't matter where it is, memory, it could be our screen memory, it could be anything. It's going to do something, and that's why Fabio called it fill mem. So this is the routine. So of course we need the source where we have our, the destination where we have our bit plane data, where it's our bit plane, and this is our data, the data that we have that we're going to display, which is 16 by 15. So those are the addresses, and we store them in 80 and A3. And the reason why we do that is, of course, you're going to realize that we're going to change, the value in 80 where we blit. We make sure we wait for the blitter to be available. Okay, I'm just checking if there's okay. So as I was saying, we wait for the blitter that is available to us and it has finished its job. I will be explaining this later on. For now, you need to accept that this is the value that we need to have in register 44. Okay, now the source and destination modulo size. For source is 0, for destination is 38. We have a 16 pixels, so one word, which is 2 bytes, so it is 38 for a screen that is 320 pixels wide, which is 40 bytes wide. BlitCon 1, for now, I will come to this register. For now, accept that it is, we're not using any special modes. We're always using area mode on the blitter. So that means we're copying an area to somewhere else. Okay, we're not using line mode. Okay, if that's what I meant. we are copying a block of memory from one place to another, so this is the value that we need to have. And then blitcon 0, where I will explain in detail a bit more in a minute blitcon 0, but for now you need to accept that 9 means we are enabling register channel A and channel D, and F0 is the min term. The 0 here, I will come to it when we do shifting. So this is where the loop starts. We are telling it that we have 16, of course minus 1 because there's the 0, we start from 0, 16 vertical positions where we will print on the screen. We are telling it also that there are 20 positions, okay, 0 to 19, horizontally. Then we do our blit, or start our blit. What we do, we move the address of the destination, which is our bit plane, to register 54, which is the address pointer for channel D, and we move the content of A3, which is the address where our figure is, into channel A, okay, to channel A pointer. Then we do our blit size, okay, we do our blit, and the blit is, as you can see, one word, 15 lines, okay, or 15 rasters, 15 lines, 15 pixels. Call them what you like, but it is 15 height, okay. We test that the blitter has finished its job to print. So on your screen you see the pattern, right, on the lower right hand corner. To print the next image on the screen, we need to increase by one word, that is 2 bytes. Hence we increase at 2, okay, to 80. Remember 80 is our bit plane pointer, where we are on the bit plane, and we decrement the 0. The 0 is controlling where we are in the X position, and we do the loop. Once we finish, so we print the 20 of this image across the screen in the X, we go and add the height of a line. The height of a line is, okay, 40 bytes, of course, across. We have 40 bytes across the screen, and the height of the image, which is 15. So we need to skip this value, okay, to be in the second line. We add that to 80, and we do the loop 16 times. That's basically it. This is the image that we are, the image that we have on the screen, the data for it. But as I said, this is one bit plane. There is nothing else that I think, he's here, okay, I'm not highlighted. If I did not highlight it, it means that I've just said it, okay. He is explaining what I just explained. I prefer that you see the code, not seeing the text. And that is our example. Let's do number 9C3. So you tell me, what is this? Okay, so here we have a blit of one line. Okay, so I was saying that what we have on the screen is a blit of one line. Okay, well, we have a data for one line. Let me correct that. We have the data for one line. Okay, we are doing a blit, okay, but we are using a modulo of -40, so we are blitting the same line, okay, several times further down. I think it's 10 times, if I remember correctly the code. So we have 8 words, because that is formed from 8 words. Okay, on the screen we have a pattern of 8 words. We are blitting it 10 times across the screen. But here is the difference between blitter when you use modulo of a minus and screen when you use modulo of a minus. The screen, and when you do a modulo with a -40, the effect that you see on the screen is only visual. It's not affecting memory. The blitter writes to memory all the time, so it is affecting memory. That is the difference between the both. So note that, because it is something that how to say, that might escape, you know. I mean, -40 with modulo on the screen when we are using the copper, it's just visible. There's nothing that is really happening in memory. It's just happening on the screen. But in the case of blitter, it is happening in memory. So this can be something that you are doing. You're not actually seeing it, but note that it has an effect on the memory. So let me go to the book and explain it. To be fair, the code is the same as what we had practically, but you're going to see a small of what we had in example 1, okay? But you're going to see a slight change, okay? So here, okay, so Fabio here is saying what register 44 and 46 are, okay? But he hasn't explained them yet. So normally you see I highlight it with red when they are not explained yet in the book. In this case, in his comments, he explained them, but he hasn't done it. So I should have done these in red, but because he said what they are, I left them as pink in this case. But what it is the mask for channel A, and it is the first word and the second word related to channel A. However, we'll come to that at a later stage. So just accept that we need to have FF in both of them. Again, BlitCon 0 doesn't change. We have the 9 and the F0. So 9 is for channel A and D, and the min term is F0, as you see here. BlitCon 1, accept that is at 0, and I will explain that later on. Actually, while we stop here, let me stop a little bit here and I show you something. Okay, so hopefully this will help better. 2 seconds, so still I find the page. Okay. Yes. Okay, so we have the register 040 and 042, BlitCon 0 and BlitCon 1. Okay, so I just wanted to make you aware that these two registers, you see there's a line here, and it's the same registers, okay? BlitCon 1 and BlitCon 0. The blitter has modes in what it can operate in. It's area mode, what I was saying, and line mode, okay? Also, I was saying that we have 9FO in register BlitCon 0, okay, and 0 in BlitCon 1. Now, For now, ignore these, okay? Bit 12 to 15. I'm going to come to them later when we do shifting. These are we already covered this, but I'm just showing you a visual thing now of it. These 4 bits, okay, 8 to 11, okay, is where we select the channel, and you can see use A, use B, use C, use D. So we have a 9, so this channel A and channel D are on. We have F0 for the midterm, so which we haven't really done with midterm yet, but know that that byte, okay, F0 is these 8 bits that we have here. As I said, these 4 bits I will be explaining them in a minute at the end of the stream, basically. In line mode, we will be seeing this later on in the second chapter related to the blitter. So for now, just accept that we are not using this mode, but always this mode for now, till I say so. And remember, we are working with 1 bit plane also. So let's go back to the book, which you see and I don't. And let's continue from where we were. So I explained this SplitCon 1, showed it to you, highlighted to you, and then we do the modulo. The modulo for channel D of the blitter is, of course, 20. How many we have? Okay, how many words we have? Minus 8. We are using 8 words on the screen, times 2 to get it in bytes. Remember, the modulo is the only is needed in bytes. Okay, and here we have the modulo for the A channel, which is minus 16. Minus 16 is, remember, our screen, what we are splitting on the screen is 8 words. So he put minus 16, so we are going back on, let's say, on what we blitted, okay, from the first line. And so that means we are going to blit always the same line here, and I'm going to show you this. We are putting the address of the register of channel A into register 50, the address pointer. Let me show you the figura, what it is. So, as I said, our image is only 1 line that consists of 8 words, and these are our pattern. It's our pattern for those 8 words that you see on the screen. But we are splitting it using the modulo of minus 16, and because of that, it repeats. So this is the address for channel A, and here we have the address for channel D. Now, this is calculated by if the position where we want it is to be x32, pixel 32, and line raster line number 4. As you can see, it's a bit further down from the edges of the screen. So we are in line 4. Because each line is 20 words, okay, so we do 4 times 20. Then because we in the X position we are 32 and we need to specify in words, in this case, bear with me a second, so 32 division by 16, we get 2. Then the sum of this, we multiply it by 2 to get the value in bytes. That value in bytes, the offset from the start of the bit plane, we add it to the bit plane address, and we get the destination address where we want to do the blit. Here we do the blit. So I told you, yes, I'm right. So the width of our blit is 8 words, okay, and the height is 10 lines. Okay, so that is our blit. I have written it here. The 10 here is the height of the image, but in reality we just took one line and we are copying it 10 times, okay, because of the modulo. And that is basically the example. I don't think there is more to it. Here Fabio is saying, okay, what I just said and which I highlighted, that using the splitter with a modulo of a minus, the effect is on the memory, while a modulo with the copper on the screen is just a visual thing. That's basically it, and this is the lesson that you need to learn, okay? The point, the nugget that you need to learn in relation to the difference between the modulo of the splitter and the modulo of the copper. I'm not sure if we need to do D1. Let me check. Yes, we do D1. Okay. So let's switch to the Amiga and do D1, show you D1, what it does. So now we have an image on the screen, okay, that is being copied, okay, across the screen going down, okay. We are still with using 1-bit plane, but we have managed to make it move now, okay, and we are moving it vertically one line at a time. So we are able, you're starting to getting the feel of a sprite being moved on the screen, okay? I mean, it's not there yet, okay? But you're just getting the idea of it. So let me go to the book. I don't know if you have, I mean, there's something that I need to, those that have a little idea why we have the line on the screen might have a guess why we might have a line on a screen. You know, when it's going down, it's leaving a trail, the image is leaving a trail behind it. Why we have that? I will mention it in a minute, but I'm pretty sure there are people out there that will spot this, why we are having that, because that shouldn't happen, to be fair. Imagine it going down without those two lines, okay, those two rails, whatever you want to call it, rails. So what we do is we're going to initialize D7, okay, with a value of 150, but the 150, so we are going to scroll it 150 lines down, but actually what we need to scroll it is 150 minus 6, which is the height of the image, and then of course minus 1 because we start from 0. So that's how many times we're going to move it in the y direction. Here we see it moving slowly down, okay, because we are waiting for the raster line, that is raster line 264 each time. As you can see, 108 here, that's our raster line. Remember, this is the standard routine that he taught us of how to quickly test the raster line on the Amiga. And then after we test for the raster line, we check that the blitter has actually finished the usual test, and then we continue. Notice here that register 44 and 46, they are in red. Here he said he will explain them later on. So that was a mistake in the previous, not mistake, but you know, he said what it is in the comments, but probably he didn't want to say it because he hasn't explained it yet. So for now, accept the values of f's in them. Then BlitCon 0, as always, we have the 9FO. Okay, so 9 is channel A and D, and we have a midterm of F0. BlitCon 1, it is at 0 for the reason that I explained earlier, but we will explain them later on. And now we arrive to the modulo. The modulo of our image is 0 because that's how big the image is. There's nothing to skip. Okay, so we are not copying it from the screen, from somewhere in the screen to somewhere else, but so that's what it is. And because our image is 2 words, okay, so that means 4 bytes, we have 36. As you can see here, he's doing 40 minus 4, which is 36. 4 is because the image is 2 bytes, 2 words, sorry. Here he's passing the address pointer for the image, and here he's passing the calculation of where the destination on the bit plane is, which we have initialized to the first part on the screen, the first word, sorry, 2 words on the screen. You can see that our image is 2 words, so the width is 2 words and the height is 6. Of course, once we have blitted the image, we need to add 40 because we need to blit it to the next line. So we need to add 40 bytes, okay, to the 80. Okay, the rest remains the same, and we do the loop, and we blit 150 minus 6 to the screen the image that we have. So the missing part, why we have the trace here, for those that haven't yet figured out why we have the trace of the lines, is because we are not really clearing the screen. We are not clearing where the image was before we printed it each time. So we end up with a trail of those 2 lines. It could have been something else, but in this case it's a trail of 2 lines. That is why we need to clear the screen, which we will come in a minute, but that is the issue that we have here. Not issue, but you know, that what we are not doing. He's, you know, remember the examples are built one on top of the other. So next example he will say that basically. I'm just giving you heads up. So yeah, for those that guessed this from the beginning, well done. This is the figure that we were copying. So as you can see, it is 1 bit plane, and it is the very good of the Amiga in 1 plane. Okay, so I believe we need to do this one too. D2, yes. So we'll do D2. As you can see, now it's going down the screen, slowly falling nicely without leaving a trail. That means we are clearing the screen now. Okay, so that's what we're going to see. Sorry. I just realized I didn't skip to the Amiga, and hence I'm going to run it again. So as you can see, it is going down slowly to the on the screen, and it is clearing. It's not leaving a trail. So now we pass to the book, and I will explain it what's happening. And it is quite easy, to be honest. So we have the 150 again. How many times we're going to move it vertically across the screen. Then we have the wait for raster 264, 264, raster line 264, 108. Then we need to make sure that the blit has finished what it was doing. And now we will do a blit, but the first thing we do is a blit using only channel D. If we use a blit using only channel D, that means we are going to clear whatever there is on the screen. Hello Ozzy, thanks for joining. So BlitCon 0 has got channel D selected, as you can see, the 1, and no min term, so nothing else. So that's channel D. We don't have any other channel except channel D. BlitCon 1 is 0 as always, and it will be explained later. The modulo for the channel D is 0. We pass the address of the bit plane, and here you can see we are doing 20 words. So the width is 20 words, which is 320 pixels or 40 bytes, with a height of 256. And that is our blit. Once it's finished, we check that it finishes. Okay. Once it finishes, we do our blit of the image, and this code is the same, identical to what we had before. So all we did is adding the clearing of the screen before we actually blit the image. That is all. It's still adding 40, and it's still doing a branch using D7, a loop for the 150. Okay, so each time decrementing that, nothing else. So the code remains the same. And as far as I know, there are no more comments. Yeah, 93, I think we haven't yet arrived there. So that was some examples related to blitz. I want to see. Okay, so D3 is actually coming. I want to see what. Yeah, so what he says here is the idea of moving sprites, doing blitz on the screen is the same as doing sprites, of having sprites. The difference between sprites and bobs, because the Amiga sprites are called bobs, those that are done with the blitter. I mean, in modern world, these are called soft sprites nowadays. But in those days, in the Amiga term, and I'm going to stick to the Amiga term, is bobs. Sprites created by the blitter are bobs. But if somebody is young and wants to use the word software sprites, it's also fine. So we let's see if I have more notes to this. Another thing, of course, you need to take care of college detection yourself, but the rest is the same. So now I'm going to present an example. The example is to introduce us to shifting, okay, using the blitter. But for now, I'm not going to cover shifting. It's just to see a problem. So let's go to the Amiga. You can see that we have an image that went across the screen. I think it's 50 times. It was scrolled across the screen. And what happened there is that it was being moved 16 pixels at a time, because right now we do not know how to move an image horizontally on the screen except 16 pixels at a time. Hence, we have a problem. How we can move an image 1 pixel at a time horizontally. We know how to do it vertically now, but we do not know how to do it horizontally. And remember, we're always using one bit plane. So let's go to the book. Actually, let me explain the exercise first. So go to the book and explain the exercise before I go into the theory. So here is the code for what we had to moving this sprite, it's software sprite or Bob, across the screen 50 times. So here is the position of X, how many times we're going to do it. Here is we wait for raster line 264. Okay, 108 is 264. Said this many times now. Here is waiting for the blit that it has finished what it was doing, and here is our clearing of the screen. Okay, so it's, as you can see, we're using only channel D. It's the same routine that we had before. Okay, and you can see that we are clearing the whole screen, which is 20 words by 256 lines. We wait for the blitter to finish, and then we blit our image to the screen horizontally. The only difference between this code and the previous code, where we were moving it in the Y direction, is that instead of adding 40, so 40 bytes for each line, because to jump to the next line we need to add 40 bytes, here we're adding 2. That is the only difference between the two. And that is why it's moving horizontally 16 pixels at a time, the image. Hence, we have a problem because we do not know what to do, how to move something on the screen as we can do with sprites, okay, hardware sprites now I'm referring to. So Fabio here says, okay, in this paragraph, if we have a car and we want to shift and we want to move this by 1 pixel at a time, how do we do this? Right now we can only move it at 16 pixels at a time. That's what he's saying roughly in that paragraph. Okay, I shorten it, but that's what he's saying. Now, this is what you need to understand. We need to make the pixels to be copied from an arbitrary position within the word itself, okay, to another position. So whatever, so we have this word, okay, it is in this case byte, but to keep it simple, he's showing a byte, but it's a word, because remember the blitter works in words. And we need to shift it, in this case, by 3. Okay, so we are shifting it 3 bits, okay, our word. And what actually happens when we shift? and if we do a shift. This is the other mystery that we don't know. Let's say we know which register to do shifting, but what actually happens? Okay. Of course, we cannot copy the image. In this situation, we need to somehow shift them without doing the copy that we were used to do. Okay. Now, I want to make sure that I do not skip anything from my notes. Okay. So, before I give the solution, know this. The Blitter has two registers not two registers, sorry, two shift registers. Okay, it's able to do two shifts. Ah, crap. I rephrase that. So, two channels of the Blitter, channel A and channel B, okay, can do shifting. Channel C is not able to do shifting, okay? And this is register 40 and register 42 of the Blitter, of the custom register, chip registers. So I'm going to bring back the diagram that I had before. Switch to it. As I said, this is bits 12 to bits 15. Please consider this area only, ignore from this line onwards, okay? And as you can see, these 4 bits in BlitCon 0 are for channel A of the Blitter, and these 4 bits, okay, are for channel B to do shifts. So we have these 4 bits to do shifts, and this gives us possibilities of 16 positions. So we can do the whole shift. So it is one word, we can shift it all. And this is how we do shifting. Well, is where we write our shifts. Let's go back to the book. Note that all blitz so far, okay, that we have done had a shift of 0. 0 means no shifting at all. Okay, as I said, it's bits 12 to 15 of BlitCon 0 and BlitCon 1. C doesn't have any shifting. Shift, this is important, okay, because something that some people might think differently. Using shifting doesn't cost anything to the Blitter. So just because we said we want to shifting at 0 and shifting 4 or 5 or 8, whatever, it doesn't cost extra to the Blitter. It takes the same amount of time. So shifting or not, the Blitter will always take the same amount of time. That was that paragraph, all the notes that I had for that paragraph. Thanks to shifting, we can design an image shifted in an X, okay, in an X position horizontally, in a different position, okay? Let's say we want our image to start at pixel 38. And I'm writing this down here also. We can do a shift by doing the following. If we have pixel 38, if we want to move it to pixel 38, the closest word to it is word 2, which is 32 pixels. So then we do 38 minus 32, which is 6. The remainder is our shift value. That is what he said in that paragraph. We take another example. In general, if x is not a multiplication, it doesn't fit, you know. In 16, when we divide it by 16, what remains is our shift value. Okay, so that is the point. If we have a value of, let's say we want to move our image to pixel 100, okay, 100 over 16 is 6, so we know we're going to shift it 6 words, okay. Sorry, not shift it, move it 6 words horizontally across the screen from the starting position on the left. And then if we consider it an offset of 0, okay, I'm referring to here, if we are at the top upper left hand corner and we say 100 x, okay, so y is 0 and x is 100, then it is 6 words to the right, and the remainder is 4, so 100 minus 96 basically is 4, and that is our shift. As I said, it is 6 words or 12 bytes, so when we add to the bit plane offset, we have to add 12 bytes. It is 6 words, but it is 12 bytes, and because we work in bytes. So that is that paragraph. Now, before we start, we need to understand how the shift register works, okay? And we need to answer a few questions, okay? Some bits are shifted out of the word. What happens to these? Also, what happens to the bits that come in? Okay, so also you need to keep in mind, let's say we have, as in this example, 3 words, okay? What is affected only is, let's say we are shifting by 3, it's affected this 3 bits and the last 3 bits. The rest, the printer is able to move. If we have shifted by 3, these 3 will go here, okay? So that is something that the printer can do automatically internally. What we need to do, what it does also is, and now I'm going to explain what it does. When we shift, let's say we shifted by 3, these 3 words, okay, the bits that enter in word 1, okay, are 0, okay. What enters in word 2, as I said, is the 3 bits that were in bit 0 to bit 2 of word 1. Same thing happens to word 3, but these 3 bits, for now, don't think that they are lost, but are a question mark, okay? And I'm going to show this. What happens to those 3 bits? And here I wrote a note that for now, think that they go nowhere. Actually, they go somewhere, okay? But for now, for this imaginary thing, just think that they go nowhere. Now, notice that the last 3 bits are not copied anywhere, okay? I was saying that the last 3 bits, nothing, they go somewhere, or we assume that we don't know yet what happens to them. If we take another example, when we have 3 words and 2 words and we shift by 4, we copy from channel A to channel D, shifting by 4 bits, the same thing happens, okay? What happens to the last 4 bits? Okay, where do they go? It's the same thing. So we arrived to an exercise. Okay, so that was the first part, the explanation of all this. So we are going to do, if I'm not mistaken, lesson 9E1. I will be switching to the Amiga. And let's do 9E1. So we have a blit, okay? It's a small thing, it's in the, because it's only 16 pixels. But this is to show our problem. So you think there's a fish there that is crawling from left to right, okay? In the same word. But notice it a little bit. It's going upwards a little bit, not by much, but a little bit, okay? Why is that? That is because, okay, and I can give you the answer of our problem. When we are shifting, what exits from the blitter, the last 3 bits, okay, goes into the next line, because the blitter shifts everything and considers everything as a whole shift. So there's a solution to this, and I'm going to explain the solution to this problem. First, let's explain the code that we have there. So let's shift to the book. So this is our code. Of course, the usual stuff, the startup code, which we do not need to cover. But the 0 here in D4, okay, is where we are going to have our blit on the screen. We're going to start from position 0, basically. Also, I said it, I need to correct myself here. This is the shift value. Okay, so we are going to blit at the upper left-hand corner, but also this is the shift value, so nothing is going to change. So this is the number that we will be incrementing to see these fish moving as you see on the screen. Here we are waiting for raster line 264. Okay, the 108 here is raster line 264. Here we are moving the value, so we start with 0, but of course this is going to increment. We are moving this value, okay, the value that we have in D4 into D5. And why we are doing this? Because we need to do some operations to it. Okay, so D5, we are ending D5, okay, with the word 000F. So we are only interested in the last 4 bits that we have in D4. Okay, we are shifting those last 4 bits, sorry, the first 4 bits, okay, by 12, because remember, in the register blitcon 0, they are from bit 12 to 15. So we need to shift them by 12 to the left, okay, and then we need to OR them with the value of 9FO. Remember, we were using the value 9FO. 9 is for channel A and D, and FO is the min term that still needs to be explained in the book. But for now, we need to accept that the value is F0. So, okay, we end up with a shift value in the 0, where the 0 is, and our channels, which ones we are going to activate, and what minterm we are going to use. Okay, so that's what this is doing here. We add 1 to D4, so we increment our shift register, but we haven't really applied that yet. Okay, that will be in the next loop when we action it. It's just that he's adding it already. Here we test that the blitter is free. Okay, remember, we need to make sure that the blitter is not being used. Then it's in red. This is coming later on in the book, but for now you need to accept that the values needs to be FF. Then we have the value that we stored, this value, the shift value and the 9FO, okay, that we have up here into D5. We're going to shift it, put it in register 40, okay, which is BlitCon 0, okay. BlitCon 1 will be explained later, but as we discussed, it is 0. We are not using any special modes of the blitter, always area mode, and then the modulo is 0 for our image, and for that, because of channel D, that was channel A, what I said 0, channel D is 38 because we have two words, one word. The word is 2 bytes, so 40 minus 2 is 38. Here we have our pointers, okay, one is where the image is and the other one is where the bit plane is, and then we do our blit. The blit is one line, one word, the width is one word, and the height is 6 lines, 6 raster lines, 6 pixels, whatever you want to call them. And it's doing our blit, okay, and we loop and we continue to do this, okay, till we press the left mouse button. This is what it's doing here. I did not highlight it because everybody knows now, but we test that the blitter is released basically, and then we return. So that's our code. We told the blitter to shift, okay, loop and shift. So somewhere, see, this loop is not here, okay, it's not where the mouse is, but it's going up, okay, it is here, okay, where we have already added a 1 to D4. So now we are going to work, we started with 0, we're going to work with a value of 1 and do the same calculation here so that we can have the value that we need in BlitCon 0. That's basically it for the code. So as you see, although this code works, we have a problem, and the problem is it is shown clearly on here on this diagram with my highlights. So if we shift, okay, for bits, okay, what happens to these 4 bits here? So these will shift. As you can see, we shifted this word by 4, okay, by 4 bits. Everything moved, but these 4 bits here went into the second line for the image. So that is what's happening with the fish that you saw while it is a bit shifting up a little bit. So how can we solve this problem? And the solution to it is quite simple. If this was our word, which is here down below, we add, instead of splitting instead of our image being one word, we use two words, and in front of it we have a word that contains zeros. So when we shift, okay, when we shift by 4, these 4, instead of moving down here, will move down, will move here on this line, okay, and the zeros that we have here, which is accepted, will go on the next lines, and like that, okay, we solve our problem that we have on our screen by using the Blit Shifting and using the exact dimensions of the image that we have, while actually we need to enhance it, let's say, with a word in front of it. So to be able to shift to the right. So I'm going to show you the next example. So let's go to the Amiga and let's do the next example. I will not finish shifting, and the reason why is next week I want to do a revision of it because it's quite crucial, this part. So now you can see that we have like a jumping fish or I don't know, elastic fish that going forward and then goes backwards. But the scope of this code is to show you that we are shifting the fish by 16 pixels to the right, and then when we reach 15 we start again from 0, so it moves backwards. Remember, 0 is no shifting at all, and then it's always shifting to the right. The Blitter can do shifting to the right for now, okay? I will come to shifting to the left. For now it is shifting to the right. So let's go and check the code for this. Let's switch to the book and we go to the, remember there are two books. One is the theory book and one is the exercises book. The theory book is 400 pages. The exercises book is 1872 pages. So we are on that book. So how is this being done? How we have done the shifting? So it is, I'm just going to give you a heads up. It is practically the same code, but what we did, it continues to scroll. Okay, you can see that our image has got a word of zeros in front of it. That's why we are able to shift each position. Hence, going through the code, you will see that we still have this D4 starting at 0. We wait for raster line 264, okay, this part where I'm highlighting. Then that's still part of the wait. Then we are doing our calculation with the value that we had in D4. We move it to D5 and then we do our calculation, okay, which is the same, nothing changed. Okay, we add 1 to the shift register, to our shift counter, let's say that we are using for shifting, and then we do our Blit. This code is identical to what we had before. Okay, we have to accept these two with the default values that we have. D5 is the calculation that we had above here. So we have in BlitCon 0, okay, we have the shift value, okay, we have the channels, which we are using A and D, and we have the min tab. And for those that have already forgotten, I'm just going to bring back the browser. Sorry, let me stay on the book till I sort it out. So, because I was not on the page, that's why. So the browser, and I need, as you can see, the BlitCon 0, okay? Remember, we are doing shifting. We are the first 4 bits, sorry, the upper 4 bits are our shift register, what we have been manipulating. The next 4 bits are which channels we are going to use, and here we are specifying the min term. BlitCon 1, okay, has got also a shift register for channel B. For now, ignore everything here and everything that is related to line mode of the blitter. We are always using area mode. So what we are really interested is in this column, okay? Let's go back to the book. And once we have the D5 calculated, we have incremented the shift register again, we store that value into BlitCon 0, which I had just explained and show you the diagram. Then we use our modulo. Remember, for the source it's 0 because the image has it's not part of a bigger image. That's what it is. There's nothing to add to the modulo. So that it's what it is. What we lit on the screen, remember, and this is the change, okay? This is, remember, before we were doing 40 minus 2, which was 38. We only had one word, okay? Now we have 2 words, so it's minus 4, so the value is 36. So the modulo is the only thing that changed, plus adding a word in front of our image to make it 2 words, hence the modulo of 36. The same thing with Blit with the source and destination addresses, okay? These are the source and destination addresses, and then we do our Blit. And this time, instead of specifying 1 word, we have 2 words, and the height remains the same, 6. That's basically it, and we continue to loop. I remind you that the loop here goes up in the source, where we continue to increment and loop and show the fish that moves, that is shifted by 16 pixels, 1 by 1. This shifting is important because this is how many things that use the blitter perform. Things like scrolling, like when you have a scroll text. Many things that the scroll text is used by using hardware scroll. Most of the time, it is done by the blitter, not by using hardware scroll. I mean, you can use hardware scroll, so I've seen it in both, but most of the time it's handled by the blitter. It has other advantages of using the blitter in terms of when you are manipulating images on the screen. So this is why shifting is important, and I do not want to do all the chapter because I want to do a revision of it in the next week, because we will be using shifting quite a bit, and it's an important topic to know how shifting works. So if we go back to the theory book, this is where I I basically finished yesterday. So remember, I'm keeping in sync the Italian version with the English version before I had a mess. So this is really working well, keeping them in sync. I hope you enjoyed it. Thank you very much, and hope to see you next week. We will continue with the Blitter, and we will do now, because we have only been covering one bit plane, so we will do color next week, and we'll be doing things related to color when shifting to with color. So thank you very much, and hope to see you next week. Bye bye, ciao.